Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Functions in Python, Part 5, for the class 12 students of Computer Science. In this video, we are going to learn passing mutable and immutable objects to functions, passing arrays or lists to functions, passing strings to a function, passing tuple to a function, passing dictionary to a function. So let's dive in and get started. Understanding how Python sees objects is a key to becoming a better Python programmer. At first, let us know what are Python objects. In Python, everything is an object, including integers, lists, and even functions. This means that every value, variable, function, or data structure you encounter is an instance of a class and has associated attributes and methods. Let's verify using the interpreter. Now look at example 1. Integers as objects. In line 1 of example 1, it assigns the value 5 to the variable x. In Python, integers are objects, so x becomes an object of the int class with the value 5. In line 2, the bit_length method is called on the x object. This method returns the number of bits required to represent the integer value of x. In this case, x has the value 5, which can be represented with 3 bits, 101. So the output displayed is 3. Example 2. Lists as objects. Here, my_list is an object of the list class. It has methods like append, which can be used to modify the list by adding elements. The output displayed is list containing elements 1, 2, 3, 4. Now look at example 3. Functions as objects. In Python, functions are also objects. They can be assigned to variables, passed as arguments, and have attributes. In this example, greet is an object of the function class, and we can call it like any other object. So everything in Python is an object. Let's learn about the use of id and use of is to deepen our understanding of what's happening under the hood when using Python to create and modify objects. Python has a built-in function, id, which returns the address of an object in memory. In this example, we created an object by the name of x and assigned it the value of 2. We then used id of x and discovered that this object is found at the address 139804188311824 in memory. The function id of object returns the address of object in memory. This allows us to check interesting things about Python. Let's say we create two variables in Python, one by the name of x and one by the name of y, and assign them the same value. Now look at this example. Both variable x and y holds the string Python programming. Now, in line 5, we are using the equality operator to verify that they indeed have the same value in Python's eyes. Yes, look at the output, it's true. But are these the same object in memory? In theory, there can be two very different scenarios here. Now, look at picture 1. According to the picture 1, we really have two different objects, one by the name of x and another by the name of y, that just happen to have the same value. Now look at picture 2. Yet, it could also be the case that Python actually stores here only one object, which has two names that reference it, as shown in picture 2. Now, we can use the id function to check this. So as we can see, Python's behavior matches picture 1, described in the previous screen. Even though x is equal to y in this example, that is, x and y have the same values, they are different objects in memory. This is because, look at line 8, id of x not equal to id of y, the output is false. Now, look at line 9 and 10. There is a shorter way to make the comparison given, and that is to use Python's is operator. Checking whether x is y is the same as checking id of x equal to id of y, which means whether x and y are the same object in memory. Here the output is true. We have said that everything in Python is an object, yet there is an important distinction between objects. Some objects are mutable while some are immutable. An object whose internal state can be changed is called mutable. Example: list, set, dictionary. An object whose internal state cannot be changed is called immutable. Example: number, string, tuple. Let's see about immutable objects. An object whose internal state cannot be changed is called immutable. For example, int objects are immutable in Python. Look at example 1. What will happen if we try to change the value of an int object? Well, it seems that we changed x successfully from 53,045 to 53046. What exactly has happened here? Let's use ID to further investigate. Now look at example 2. X is assigned value 53045 and the ID is noted. In line 5 onwards, we can see that by assigning x equals 53,046, we didn't change the value of the object that x had been bound to before. Rather, we created a new object and bound the name x to it. So the ID is different. Now, look at picture 1. So after assigning 53045 to x by using x equals 53,045, we had this state. Now, look at picture 2. And after using x equals 53,046, we created a new object and bound the name x to this new object. The other object with the value of 53,045 is no longer reachable by x, or any other name in this case. Whenever we assign a new value to a name, in this example, x, that is bound to an int object, we actually change the binding of that name to another object. So the IDs are different. The same applies for tuples, strings, str objects, and bools as well. In other words, int and other number types such as float, tuple, bool, and str objects are immutable. An object whose internal state can be changed is called mutable. For example, we know that we can modify the contents of a list object. Now, look at example 1. The first line initializes a list called my_list with 3 elements, 5, 20, and 30. The second line modifies the first element of my_list by assigning the value 10 to my_list of 0. In Python, list indices start from 0, so my_list of 0 refers to the first element of the list. Finally, the third line prints the modified list my_list. Does that mean we actually created a new object when assigning a new value to the first element of my_list? Again, we can use ID to check. Now, look at example 2. Both IDs are same. Look at picture 1. So our first assignment my_list equals 5, 20, and 30 created an object in the address 140167178840256 with the values of 5, 20, and 30. Now, look at the second picture. We then modified the first element of this list object using my_list of 0 equals 10, that is, without creating a new list object. And hence the address is the same, with the values 10, 20, 30. In the previous video, we have passed single constant value to functions either through positional arguments or through keyword arguments. In Python, we can pass multiple values to the function using lists, tuples, dictionary, etc. In Python, objects can be categorized as either mutable or immutable. Immutable objects, such as numbers, strings, and tuples, cannot be modified after creation. When passing an immutable object as an argument to a function, the function receives a copy of the object's value. Modifying an immutable object within a function only affects the local copy and does not impact the original object outside the function. This behavior is known as pass-by-value for immutable objects. Mutable objects, such as lists and dictionaries, can be changed after they are created. When passing a mutable object to a function, the function receives a reference to the original object. Any modifications made to the mutable object within the function will affect the original object outside the function as well. Mutable objects are passed by reference in this case. Now, we are in the topic passing arrays or lists to functions. But before that, let's see the difference between an array and a list. Data type. Lists can store elements of different data types, while arrays typically store elements of the same data type. Mutability. Lists are mutable, allowing for modifications to the elements, whereas arrays can be mutable or immutable depending on the underlying data type. Functionality. Lists provide general-purpose functionality for data manipulation, while arrays are optimized for numerical computations and offer specific mathematical operations. Memory overhead. Lists have a higher memory overhead compared to arrays because of their additional functionality and flexibility. Availability. Lists are a built-in data structure in Python and readily available, while arrays require the array module to be imported. Indexing. Both lists and arrays use zero-based indexing, allowing access to elements by their index position. Dynamic resizing. Lists have dynamic resizing, meaning they can grow or shrink as needed, while arrays can be fixed size or resizable, depending on the implementation. Element types. Lists can store elements of different data types, making them heterogeneous, while arrays typically store elements of the same data type, making them homogeneous. Methods. Lists provide a wide range of built-in methods for general-purpose data manipulation, while arrays offer specialized methods for mathematical computations and operations. When working with arrays or lists in Python, passing them to functions involves some considerations. Let's see the summary of passing arrays or lists to functions. Arrays or lists can be passed as arguments to functions in Python. By default, when an array or list is passed to a function, the function receives a reference to the original object. Any modifications made to the array or list within the function will affect the original object. This behavior is due to the fact that arrays or lists are mutable objects. Modifying the array or list within the function will persist even after the function returns. It is important to understand that the reference to the original array or list is passed, not a copy of the entire object. Consequently, any changes made to the array or list within the function will be reflected in the original object outside the function's scope. You can pass a list as an argument of a Python function the same way as any other type, and it will be the same type inside the function. Let's see an example. In this example, a list named my_list is defined with the values 1, 2, 3. Now, look at line 3. A function called my_func is defined that takes a list as an argument. In line 4 and 5, within the function, there is a for loop that iterates over each element in the list_as_argument and prints each element. In line 7, after defining the function, you call my_func with the my_list as an argument, which means the elements of my_list will be printed by the function as 1, 2, and 3. Finally, in line 8, outside the function, you print the my_list again. This will print the list as it is, without any changes made by the function. The output is list containing 1, 2, and 3. There is a list of 3 numbers. You can pass this list as an argument and display all its elements one by one. If you print a list after the function execution, it will print the same numbers. Because lists are mutable, when you pass a list as an argument, you create a reference to this list and not a copy. Now look at example 2. Look at line 6, the same example, but if you print a list after the function execution, it will print the same numbers. Because lists are mutable, when you pass a list as an argument, you create a reference to this list and not a copy. Check the output displayed on the console. Now, in example 3, in line 4, we are modifying the list. After you modify this list, the modification will apply to the list outside the function because it was a reference and not a copy. Any modifications made to the array or list within the function will affect the original object because lists are mutable objects. Consequently, any changes made to the array or list within the function will be reflected in the original object outside the function's scope. Check the output displayed on the console. Let's see how to create a copy of a list. Look at line 4. If you want to modify the list as a copy of the one inside parameter, you can use the copy function. Look at the output. Now, if you run the code, the modification inside the function doesn't apply to the my_list list, because the function operates on a copy and not on the original object. Let's discuss about passing strings to a function. Strings can be passed to a function as an argument. Since strings are immutable objects in Python, it is used as pass by value. Thus a function can access the value of a string but cannot modify it. If you wish to modify a string, the solution is to create another, new, string and concatenate the modified value of parameter string in the newly created string. Now, in this example, two strings are passed as arguments to the user-defined function, my_str, by giving two function calls. These string messages are received as a parameter in the function definition and finally printed. Let's see another example. User-defined function to accept a string as input and to count and return total number of vowels present in it. The code defines a function named countVowels that takes a string, str, as an argument. This function counts the number of vowels, both lowercase and uppercase, present in the input string and returns the count. In line 1 and 2, in the countVowels function, a variable count is initialized to 0. In line 3, a for loop iterates over each character, ch, in the input string, str. In line 4, for each character, the code checks if it is present in the string aeiou, which contains all the lowercase and uppercase vowels. In line 5, if a character is found to be a vowel, the count variable is incremented by 1. In line 6, finally, the function returns the count value. In line 10, in the main code section, the user is prompted to enter a string using the input function. The entered string is stored in the str_input variable. In line 11, the countVowels function is called with str_input as an argument, and the returned count value is stored in the count variable. In line 12, lastly, the total count of vowels is printed using the print statement. When you run the code, it will prompt you to enter a string. After entering the string, the code will count the number of vowels in it and display the result. You can check the output on the console. The string entered here is we are learning functions in Python. Total number of vowels present in the string are 11. Let's see how to pass tuple to a function. Tuples can be passed to a function as an argument. Since tuples are immutable objects in Python, a function can only access the value of a tuple but cannot modify it. Let's see an example. In line 1, in the given code, there is a function called fun1 that takes a single argument x. In line 2, x equals list of x. The x tuple is converted to a list. This is done to allow modification of its elements since tuples are immutable in Python. Now, look at line 3. In line 3, x of 0 equals x of 0 times 2. Look at the side calculation. I have marked the index 0 and 1 for values 10 and 20. The first element of the x list, 10, is multiplied by 2 and assigned back to the same position. This doubles the value of the first element as 10 times 2 as 20. In line 4, x of 0 equals x of 1 plus 10. The value of the first element, now 20, is updated to be the sum of the second element 20 plus 10. This means the value of the first element becomes 20, which is the original value of the second element plus 10. So value of first element becomes 30. In line 5, the modified list x is printed inside the function. Look at the output. Value inside function is list of 30, 20. Outside the function, the following steps are executed. In line 6, tup equals 10, 20. A tuple tup with values 10 and 20 is created. In line 7, print tup. The original tuple tup is printed. It outputs tuple containing 10, 20. In line 8, fun1 of tup. The fun1 function is called with the tup tuple as an argument. This means the x parameter inside the function will reference the same tuple object. In line 8, print tup. The original tuple tup is printed again. This outputs tuple containing 10, 20. The important thing to note is that tuples are immutable in Python, meaning their values cannot be changed once assigned. However, when the tup tuple is converted to a list inside the fun1 function, modifications can be made to the list elements. However, these modifications do not affect the original tuple referenced by tup outside the function, which is why the final output of print tup remains unchanged as tuple holding elements 10 and 20. Example 2. Let's write a Python program to input elements in a tuple and pass it to a function to determine the total number of even and odd numbers in it. Now, look at line 1. The given code defines a function countOf of tup that takes a tuple tup as an argument. The function counts the number of even and odd numbers in the tuple and returns a tuple of countEven, countOdd with the respective counts. Now, look at line 2 and 3. CountEven equals 0 and countOdd equals 0. Two variables are initialized to keep track of the counts of even and odd numbers in the tuple. In line 4, for I in tup. This loop iterates over each element I in the tup tuple. In line 5, if I mod 2 equal to 0. This condition checks if the current element I is divisible by 2 without a remainder, that is, if it is an even number. In line 6, countEven plus equals 1. If the current element is even, the countEven variable is increment by 1. In line 7, else. If the current element is not even, that is, it is odd, this block is executed. In line 8, countOdd plus equals 1. If the current element is odd, the countOdd variable is increment by 1. In line 9, return countEven, countOdd. The function returns a tuple, countEven, countOdd, containing the final counts of even and odd numbers. The rest of the code outside the function performs the following steps. In line 10, tup1 equals empty. An empty tuple tup1 is initialized. In line 11, n equals int of input of, enter the total elements in a tuple. The user is prompted to enter the total number of elements in the tuple. In line 12, for I in range of n, this loop iterates n times. In line 13, number equals int of, input of enter the number. The user is prompted to enter a number. In line 14, tup1 equals tup1 plus, number. The entered number is added to the tup1 tuple using tuple concatenation. In line 15, count_stats equals countOf of, tup1. The countOf function is called with the tup1 tuple as an argument, and the return tuple, countEven, countOdd, is assigned to the count_stats variable. In line 16, print, even numbers are, count_stats of index 0. The count of even numbers is printed. In line 17, print, odd numbers are, count_stats of index 1. The count of odd numbers is printed. Overall, this code allows the user to enter a tuple of numbers and then counts the number of even and odd numbers in that tuple, displaying the results accordingly. Let's discuss about passing dictionary in a function. Dictionary can be passed to a function as an argument. Since dictionaries are mutable objects in Python, a function can alter the values of dictionary in place. Let's see an example. Now, look at line 1. In the code, the marks_increase function takes a student dictionary, stud, and an increment value, p. In line 2 and 3, inside the function, it accesses the marks and status values of the dictionary and modifies them accordingly. In line 5 and 6. After defining the function, two student dictionaries, student1 and student2, are created with different initial values for the marks and status keys. In line 7 and 8, the marks_increase function is then called twice, passing student1 with an increment of 50 and student2 with an increment of 60. This updates the marks and status values in the respective dictionaries. Finally, in line 9 and 10, the updated student1 and student2 dictionaries are printed, displaying the modified values for marks and status keys. The output will be as shown on the console. Thanks for watching. Watch the upcoming videos. Functions in Python Part 6. Scope of variables. Global scope and local scope. You can check the link in the description box below.